Hello, it's Keith here, and this is lesson 13 of the simple series of my Z80 assembly programming tutorials. Today we're going to be looking at the Enterprise, and we're going to learn how to extend our previous drawing a bitmap smiley face onto the screen, and we're going to make it movable with the joystick. In today's example, we're going to use the joystick that's built into the Enterprise, which is effectively part of the keyboard. So let's have a look at our code and see what we'll be doing. So here's the example we'll be running today. And if I just start up my Enterprise emulator, we see we've got a smiley face. And if I press my cursor keys here, we can move around the screen. But whenever I get to the edge of the screen, the smiley face will stop. It won't go over the edges of the boundaries of the screen. So that's what we're going to be looking at today. Okay. Well, the first thing we've got to do is we've got to define a header for our file here. So we've got the starting point of our code, which we're loading into F0. We've got the header data here, which is just the length of the file. It's spelt rather badly. That should be the length. And someone used bytes. And then our program effectively starts at hexadecimal 100. We've got a stack pointer definition here. We're starting up our screen. This is very complicated. I'm not going to go into it, but you can see it all just here. I did go over that in my bitmap series if you really want to know more about it, but we can just use it as is to set up a screen. And then we need to connect to our keyboard. We're going to use an EXOS call here, EXOS 11. Now, some assemblers might show this as a command called EXOS, but it's actually an RST. It's RST48. So I'm going to show it as RST48 just for clarity. And so we're going to open the stream with command 1. We have to pass this and a stream number. I'm using stream 11 as the keyboard, and we need to give it a name for the stream. And the device we're opening is keyboard : so we've passed that name here, and we pass that in DE here, and we call that RST. So this one byte here will be skipped over by the RST call, so our next command that will be executed will be here. Now we're going to start our drawing. This code here will read in from the keyboard, but the first time we actually need to just show the starting position of the character, and this is an infinite loop until a key is pressed, so we need to skip over that the first time we run. But after that we will read in from the keyboard, and let's have a look at this test char command here. It's made up of two EXOS calls. The first one is going to read the channel and see if any data is waiting. The second one will read in the character if there is one waiting. Now, if we were just going to read in characters, we could just use the second one just here. And this is our EXOS call 5 here. And it will read in from channel 11, specified in the accumulator, and it will return a character in B. But if no character is waiting, this will just wait infinitely. Now, in theory, that would be fine because our example code here is actually just looping until we've got a key press. But if you were writing some kind of game where you're playing against the CPU, that would be completely inappropriate. Obviously, you'd need to be processing other commands while the player hasn't pressed a key. So to just make this code as useful to you as possible, we're actually testing a character and returning if no character's waiting. And to test for a character, we use EXOS call 9, and then we can load in from C here, and it will be 0 if it's ready and non-zero if it's not ready. So if there's no character waiting, we just dump down to here, returning A as 0. But if there is a character waiting, then we read the character in with this call here. Now, that's a bit complicated, but the long and the short of it is if you've opened channel 11 as the keyboard, then you can use this test char function, and that will read in from the keyboard here. So this line's actually not needed. That's from the MSX example. I left that in by accident. So we call our test char here, see if there's no key pressed, and we loop until there is one. Now we're going to start drawing our character here. So we're backing up the key press here, and then we are using some variables. Now these variables are defined just here. So we've got an X and a Y position, a single byte for both, and a backup for the previous position, a single byte for both. And of course we've got our sprites. We've got our original smiley sprite, but we've also got a blank sprite. And we've slightly tweaked the code that draws the sprite just to either draw the sprite as a smiley face or to blank it out. And we'll see both in use here. So we back up the current X and Y position, and then we clear the sprite from the screen in its current position because we're assuming it's going to move because some kind of key's been pressed. We then go through here comparing for the up, down, left and right, and each time we compare with this is the key press for the up command. If the key press isn't matched, then the up isn't pressed, so we jump to here. If it is pressed, then we subtract 4 from C here, and we do the same for down, left and right here. You'll notice we're moving by 4 lines here, but a single byte for left and right. Now, if you look just here, you can see here are the key presses that the keyboard actually returns for the up, down, left and right keys. And once we've got to here, we've moved the sprite accordingly depending on the key presses, and now we store the new position of the sprite in X and Y here. The next thing we want to do is check for the boundaries of the screen, because if we go over the screen it won't just make a mess, it will actually potentially corrupt our code. So the way we're doing this here is we are comparing to the far right hand side of the playing area, 80 bytes across, 200 tall, but we're subtracting the width and height of the sprite as well. Now if you think about it, the top left corner of the screen is 0. If you subtract 1 from 0 in a single byte, it rotates round back to 255. So we only need to check the top boundary to make sure we're still on the valid area of the screen, because if we go beneath 0, we actually end up above the valid area of the screen either way. So we do some comparisons here, and if the player's position is okay, then we go down to this draw player. If it's not, then we restore the player's position from that backup. We then run the draw player routine, which will draw our test sprite to the screen. We saw the code for that last time. And then we just do a simple pause and then we repeat. And that's really all there is to it. So that's how we get our smiley face to the screen. Now it should be pointed out that the Enterprise does have proper external joysticks, and reading those is quite different obviously. So if you want to look at those, I have covered those in a previous tutorial, but I think if you're just starting out, you're going to be best at trying to make your single player game with the internal joystick, because you know every user is going to have that. If you're doing a 2-player game, of course, that'd be very different, but as I say, when you've got an internal joystick, that would be the starting point for your simple game. And if you want to do fire buttons, then you would use the space key. I believe that's the standard for the Enterprise. So there we go, a very easy introduction there to getting some graphics onto the screen. Now, of course, you can extend this in any way you want. I hope it's of some interest to you. We've looked at now drawing sprites to the screen and how to read input, so you've got all of the basics you should need to get a simple game started. If you want to look at things like sound later on, then I've got separate tutorials that cover that kind of thing, but this should really be enough for you to, have some fun with the system and make something that's starting to look like a legitimate game. Anyway, I hope you've enjoyed this. I hope you found it interesting. Please like and subscribe if you have, because I've got lots of Enterprise content on my site, and I'm sure there'll be more coming in the future. Thanks for watching today anyway, and goodbye.